2 kg. And I see that some 10 Newton force is applying in this side so that they are accelerating, all the three blocks are accelerating in this direction with A acceleration. So this was the question, right? Now the question was that how many forces are acting in this one block, in the second block, and the third block. So we have to write all the forces that are acting on this block, these blocks. So first we calculated the acceleration, right? Because they are moving with the same acceleration. So the from the Newton's per second law, we know that this is ma. F is given 10 Newton. M is total M is how much? 10 and A. So we got A, which is equal to 1 meter per second square. So we got acceleration as 1 meter per second square. Right.
Yes, sir.
Okay. So now let us write the free body diagram of this block. So let us write all the forces which are acting on this block. So first one is what, guys? First one is that we, okay, Abdul Hamid. Who is this Abdul Hamid? Okay, so the first is the weight, 5g, right? And the second one is this normal reaction. Let me write it as n. Okay. Now these how many more forces are there for this block? Can you guys tell me?
Sir, only two, right?
Only two. So what can you say about the surfaces of 5 kg and 3 kg blocks?
5 kg and 3 kg.
So their surfaces are also touching each other, right? This surface.
Yes,
So this 3 kg block will apply the force perpendicular to this one in this direction. Let me write it as into, right? And this 5 kg block will also apply the force perpendicular to this direction, right? So let me write it as into. So these are all the forces which are acting on this block, right? So let me write it with different. This is this is into, right? And then this is so these are all the forces acting on this block. Clear?
Yes, sir.
So if we draw the, let's say this one block or FBD of 5 kg block. So first is this one 5 kg, which is 5g, and then this normal reaction, and then we have this N2, and then we have this 10 Newton force, right? And then we have some acceleration in that direction. So some acceleration. Okay. But what about this orange N2? What can you, what we can say about, not this one, not this one. So we have this N, right? So this orange. And what can you say about this green N2, guys?
Sir, it is related to 3 kg, right?
Yeah. So Can we write this N2 in the right direction? Yeah.
Sir, only when we push, right?
No, no, no. I am asking that in free body diagram. So we wrote this 10 Newton, we wrote this acceleration, we wrote this normal reaction by this 3 kg block. Then we wrote the normal reaction by this surface, and then we also wrote this weight. But we have another normal reaction which is this one. So N1. So we didn't write this N1 and we didn't write this N2. Why is that? Can anybody tell? Yes.
So because there are two objects of like on the side N2 there's already an object blocking it and N1 is the ground.
Yeah. So the N1 and N2, these forces are applied by which object?
5 kg object.
5 kg block. So do we write in the free body diagram, do we write the force which is applied by the object?
No.
No, right? So that is why we don't write this N1 and N2. Is this clear, everyone?
Yes, sir.
Yes, sir.
Okay, so you guys can see it from here. So when we were doing this problem, which problem? Yeah, this problem, right? So when we were doing this problem, so this has n normal reaction applied by this surface, right? And then this had some mass, which was changed to this weight. And then this was, so this block was also applying some normal reaction to this surface, right? But we neglected this normal reaction. Why? Because it was applied by that block. So in this case, in this case, this 5 kg block. So this 5 kg of the block is applying the normal reaction to the surface, ground, and this 5 kg block is applying the normal reaction to this 3 kg block. Is this part clear, everyone?
Sorry, sir.
Yeah. So this 5 kg block is applying the normal reaction to the ground and normal reaction to this surface 3 kg block. So that is why we have neglected or we have not counted this N2 and this N1 green part. Clear, everyone?
Yes, sir.
Yes, sir.
Okay, so now let us write and remember this these three blocks are at equilibrium or they are not at equilibrium. Yes. What can you say about the equilibrium of these blocks?
They are in equilibrium
Okay, and why are you saying so, Rishita?
because uh,
Okay, so let me clarify the question once. So we have two kinds of equilibrium, right? Up, down, and right and left, right? I'm not talking about the static and dynamic equilibrium. I am saying that on this block, we can have two kinds of equilibrium. So one in the right and left direction and one in the up and down direction, right? So if I ask you guys that in the left and right direction, do we have any equilibrium? Whenever I ask about the equilibrium, what you guys check? What is the definition of equilibrium?
Sir, when F net is 0
F net is zero, which corresponds to what?
where the
and
force
Yeah.
is equal.
If force is zero, then what is zero? If force is zero,
acceleration.
then absolutely right. So whenever we want to check the equilibrium, we say that whether we are getting an acceleration or not, right? So when we studied the equilibrium, we saw that acceleration was zero, right? So
Yes,
whenever
sir.
we are getting, yeah, whenever we are getting an acceleration, then which means that it is not at equilibrium, right?
Yes, sir.
So then we cannot write all the left equal to all the right. Is this part clear?
Yes, sir.
So in the x direction, let me write in the x direction. So in the x direction, if we don't have any equilibrium, so F net is MAX. Okay, in the x direction. And let me write it as F net x. Okay, so is this part clear to everyone? Is this part clear?
Yes, sir.
And there is a sign convention. Whenever we don't have any equilibrium, so there is a sign convention. In F net, positive sign for force in the direction of acceleration. Okay, and negative sign for force opposite to the direction of force. Okay, so we are now writing the F net part. So can you tell me this 10 Newton is in the direction of acceleration or against the direction of acceleration?
In the direction of
It is right.
acceleration.
In the direction. So we will write 10 for plus. So this is plus 10. And we have this N2. So this N2 is in the direction or opposite to direction of acceleration?
Opposite.
Opposite. So we will write minus N. Okay. And then do we have any other x direction forces?
No, sir.
No. So then this would be equal to what is the mass? Guys, what is the mass of this block?
5 kg.
So we'll write 5a. Okay. Is this part clear, everyone?
Sir, why you wrote 5a?
So mass into acceleration, right? Mass is 5 and acceleration,
Oh, okay, sir.
right? So is this part clear, Ilham and Rishita?
Yes, sir.
And
Sir, in this case, mass is
Yes, sir.
one. Sorry, acceleration is one.
yeah, acceleration is 1. We have calculated this acceleration. So all these objects are experiencing the same acceleration, right? We will write part by part, we will write all the free body diagrams. Okay. So first we are
Yeah.
considering this 5 kg block. Okay. So yes, you are right. Absolutely right, Rishita. So then this is 10 minus N2 and 5A. So as Rishita said, this is 5 into 1. So we can calculate and this would be how much? So this is minus 5, which is equal to N2. So N2 is 5. Is this part clear, everyone?
Yes, sir.
So this is how we calculate N2. Okay. Now, you guys will have to tell me. Okay. So this was in the x direction. Now you guys will have to tell me what about the upward direction or y direction.
Therefore, upward we have to take J, right? J cap.
No, no, no. So y direction. Okay. So
Okay.
the object is, let me bring, yes, let me. Okay, so we have this one and let's say this one. So these are the two objects, right? So these are going in this way. Okay, these are going in this way. Is it moving like this?
No, sir.
So this is going only in the x direction. Only in the x direction do we have any other acceleration. Understood?
Yes, sir.
So if it is not moving upward or downward, so what it means?
It should be
It's
0.
Yes, yes,
it's only
exactly.
going in the x direction and acceleration is constant.
So it is moving only in the x direction, and in the y direction we have acceleration which is c, right? So
Yes, sir.
in the y direction it is not moving, which means that in y direction it is at equilibrium. This is part clear.
Yes, sir.
So which means that what is balancing at equilibrium, because a is right, and let me write it as ay equal to. So which means that n1 equal to 5g. So if you guys have any question, please ask. So if you guys have any question, please ask.
No, sir.
Okay, so yeah, then please, you guys, please note it down. So you guys first note it down, and then we'll do the uh, normal reaction of the or the free body diagram of the second one. So please note it down. Where should I put this? Yeah. So whenever you want me to scroll down the screen, guys, and if you guys have any confusion, please ask.
No, sir. Finish, sir.
Finished. So please note down this part. So whenever you guys have noted it down, please
Sir, I'm done.
Noted. Ilham and
Yes, sir.
Akib, you also. Yes, Rishida, do you have any question?
No, sir.
Okay, so now let us write all the forces on this 3 kg block. Right. So, okay. So first one is this gravity. And then the surface is applying the normal reaction. Right? Let me write it as N. Okay. And what are the other forces that we have? So this is also applying the perpendicular force in this direction. Okay. And what do we have? This N2 we have counted. Right. So what are the other forces that we have?
Sir, sorry.
Yeah. What are the other forces on this 3 kg block?
Sir, one is gravitational, one is normal,
Yeah. So
and
that
then we
we have.
can
Yeah. And then
tell N2,
N2 is there. Yeah. N2 is there. And then
And
and
then
then
another
for 2.
from 2 kg.
from 2 kg. Absolutely right. So from 2 kg, this 2 kg is applying some normal reaction to this. Let's say this is N4. Okay. And then 3 kg block is also applying. So this 3 kg block is also applying some normal reaction, which is N, right? And then
Yes, sir.
this has some acceleration. Okay. So now let us write the free body diagram of 3 kg. So for 3 kg block, right? So we have this 3 kg block, and the first one is gravity, and then this is N3, right? And then this is N2, and then this is N2. Okay. And then we have this N, right? And then we have this N4, and then we have this N, and then we have this X. Okay. So now you guys tell me, are these all the forces that we have?
Yes, sir.
Right? So we have to neglect this one, and this one in free body diagram. Why? Yes.
Sir, they are not acting. The bodies are acting at that area.
Yeah, because this is applied by the object or by the body, right?
Yes, sir.
So that is why we are not considering this in the free body diagram. So then we'll have, right, so let me erase this one. So this one is not considered. This one is not considered, and then this. Okay, so we have in two direction. We have the we can write the free body diagram, right? Equations of motion. So first one would be in the x direction. In the x direction, applying F net in x, that is MAX, right, everyone? So
Yes, sir.
first you guys tell me what would be the N2? Will it be positive or negative?
Positive.
So N2 is
Positive.
positive, right? And what about N4?
Negative.
Negative, right?
Negative.
And do we have any other force? We don't have,
No, sir.
Mm,
right? We don't
no,
have.
sir.
So then this is M is 3 and acceleration is how much?
1
1.
meter per second
Yeah.
square.
So this is N2 minus N4. This is 3. And what is the value of N2 that we got?
5n.
So 5,
5.
5, 5 dyne. We are in the M
5
case 5 Newton, right? So 5 minus N4 is so N4 is 2 Newton. Right, everyone.
Yes, sir.
Now in the y direction, we have a equal to or ay equal to 0, which means that it is at equilibrium. So which means that n3 equal to what?
3.
3g, right? This is the weight, force. We are writing the force, right? These are all forces. So 3g, which is n3 equal to 3 into 10, which is 30. So these are the things, 43 kg blocks. Understood, everyone?
Yes, sir.
Yes, sir.
Okay. Okay, so please note it down. Everyone, please note it down. And if you guys have any questions, so please don't hesitate to ask. Okay.
Finish, sir.
Finished. Rishida and Ram, what about you guys?
Some writing just good.
Yeah, okay, please.
Answer.
Done. Rishida, what about you?
Done, sir.
Okay, so now let us come back to the last one. Right. So this one is also experiencing the acceleration in this direction. Right. And it has some weight, which is 2g, and then some normal reaction applied by this surface. So that is n5. So this is also applying some normal reaction to this direction, which is right. And do we have any other forces? So N4 is there. We have already calculated. So do we have any other forces?
No, sir.
Okay, so let us write down the free body diagram of 2 kg block. Right. So for 2 kg. So we have this 2 kg block, right? And it has some weight and then normal reaction, which is what N5. And then it has some acceleration in this direction and N4 in this direction. right? So can you guys tell me, there was some another force N4 and N5, but this was applied by this object. So that is why we have not considered this one, right? So if I ask you that in X direction, in X direction, we have to apply the second law, right? Second law of motion. So F net is MAX. So what would be in here?
2 into A1.
Yeah, so in here, in right hand side, there would be 2 into A1. In left hand side, what are the forces that are there?
Sir,
Any of,
N4 is positive.
yeah, N4, and then do we have any other forces in the X direction?
A.
A is the right hand side. A is the acceleration part is in the right hand side. So then this is as Rishita was saying, 2 into 1. So N4 would be 2 into 1. Right. So that is what we got in here also. Right.
Yes, sir.
Okay. And from the equilibrium in y direction. In y direction, we have A is 0, which means that equilibrium or AY is 0. So at equilibrium,
N5 equals to 20 Newton.
yeah. So N5 equals to 2 into 10, which is 20. So these were all the forces that we calculated, N1, N2, N3, N4, and N5. So up to this point, do you guys have any questions?
No, sir.
Okay, please note down this part.
Done, sir.
Done. Okay. Okay, and
Finish, sir.
finish. Shita, what about you?
Done, sir.
Okay, so now we have a same type of question, but in a different. So in this question, we calculated normal reaction, right? In this question, we calculated normal reaction. But now we have a different kind of question. So we have same blocks, right? So we have same block. Let's say this is 5 kg, and then we have this. This is connected with some string, and then this is 3 kg, and then we have this 2 kg block, and this is pulled by let's say 20 Newton force. Okay, so if these strings are inextensible, right? Then the acceleration is, what can we say about the acceleration? Yes. So I have already told you guys that whenever we have inextensible string, so what can you say about the acceleration?
Sir, it may change.
Yeah, so all the blocks will have same acceleration. If these strings are inextensible, then all these blocks will have same acceleration. So if this is moving by a acceleration, then this will also move by a acceleration, and this will also move by a acceleration. Okay, so this
Yes, sir.
we did it in the when we were doing this. What? Yeah, so when we were doing this tension, then we saw that. Oh, so I didn't try. Did I write? Okay, so I didn't write. So whenever we have this inextensible string, right? So whenever we have, this is not stretching, right? This is inextensible. Then whatever the acceleration is force experienced by this block, so then this will experience the same acceleration. Okay,
Yes, sir.
so in here, right, in here, these are inextensible strings. So whatever the acceleration is faced by this 2 kg block, so this will also experience the same acceleration and this will also experience the same acceleration. Is this part clear?
Yes, sir.
Okay, so as you guys saw that the upper direction part doesn't contribute, right? At least for this scenario, the upper part doesn't contribute. So we will skip that part, right? Because those are at equilibrium. So we will not consider that. We'll only consider the horizontal part. Okay. So
Yes, sir.
now, yeah, now you guys tell me that in the horizontal direction, this is pulled by this 5 kg block. So what other forces are there for this block? What is the other force?
Sir, one is
Explain.
gravitational,
No, no,
5G.
I'm not asking about the gravitational part because yeah, okay. So you have this 5G and then this norm. Okay, and then you have this 3G and then this norm. So let's say, and then you have this 2G and then this norm. So I am asking that because these are at equilibrium. The upper direction part or the Y part is at equilibrium. So we will not consider that part, right? Because from that we can write N1 is 50 Newton, N2 is 30 Newton, and N3 is 20. So we are not considering that. We are only focused with this X direction. So in X direction, what are the forces that are acting on this 5 kg block?
Sir, A acceleration.
A acceleration and then
So only one.
only one. So what is this?
Gravity.
Yes, yes, Rishita. What did you say?
Nothing, sir.
Oh, anything is coming into mind, so don't hesitate, right? Okay, so what is this thing, guys? What is this thing?
Sir, acceleration, right?
No,
It
no.
is.
What is this thing? What is this material?
String.
String. So what is the property of this string? What is the thing that we understood about the string? Yes.
It extends. It can extend.
So no, no. This is inextensible. It does not extend. This is not spring. This is string. So, what are the forces that we had, guys? You guys already forgot. What are the forces that we had?
Sir, we had three
Not
forces.
The-
normal force.
So, one was the gravitational and then normal reaction, and third one was what?
Tension.
Tension. So, what applied tension? Where did
Sir,
it?
when the string is pulled by opposite sides.
Yeah. So, when it was attached with some string, right? So, when the
Yes, sir.
object was attached with some string, then the tension came, right? So, these two blocks are attached by some string. So this will experience some tension in this direction and this will experience the tension in this direction. Correct?
Sir, how come tension is in other direction?
So tension is always opposite to the direction of this string, opposite to the direction of this block. So if we have this block which is hanging, so the tension is always opposite to the direction of the block, right?
Yes, sir.
So similarly, in case of this here, understood.
Yes, sir.
And similarly, this 3 kg block will experience what? This will experience tension in this direction, and then this will experience the tension in this direction. Right? So these are the forces that we have. Understood?
Yes, sir.
Okay, so the question for you guys is that you guys have to calculate T1 and T2. But first calculate what is calculate and tell. And give me one. Yes, guys, did you calculate?
Sir, I got A.
A
I'm
equal
doing
to.
T1.
Okay, so A you got. Good. Akib has got A, and Rishita and Irfan. Guys also calculate. Okay, Amna is not here. Yes, guys.
Trying, sir.
Okay. Yes, anyone got the answer?
No, sir.
Okay, so what is the A that you guys are getting?
Sir, I got 2 meter per second square.
2 meter per second square. Good. Rishita and Aram, what do you guys get?
Sir, I got 10 meter per second.
10. Okay. And Alam, what about you?
So I got 1 meter per second.
Okay, so you guys are not in sync, right? You guys have disagreement. All the three of you have disagreement with your answer. Okay, so uh, good. So did you guys able to draw the free body diagrams of each block?
Yes, sir.
Okay, so then why didn't you get the answer?
Sir, there is nothing on the side. 5 kg.
Yeah,
Left
so
side.
the 5 kg have only tension, right?
Yes, sir.
So if you have calculated, if you have calculated the acceleration, then you can calculate T1, right? Okay, so did you guys get confused at some point?
Yes, sir.
So now let us understand this question. So what do we have? Because this is inextensible, so all will experience the same acceleration. And the force that is applied is 20 Newton. So force is M into A. And total M is how much? 532. So 10 again. And then this is A. Force is 20, so 20 by 10, which is 2 meter per second. That is this part clear, everyone?
Yes, sir.
Yes, sir.
So A is 2 meter per second square. Now if we write the free body diagram, so I just let me write it. So now F is M. So I'm only writing the X part. So this is 20 and 10A. So A is 2 meter. Now for 5 kg block. As you guys have already drew the free body diagram, so free body diagram is this is 5G and this is N. So we are not considering the y direction equation. So we are writing the equation of motion. Equation of motion of the x direction. So F net is in x direction is ma x, right? So F net is, as you can see, that it is acceleration is in this direction. So what would be in here?
Sir, nothing.
We don't have anything in
N1.
the n1 in x direction.
Sir, in X direction we are having tension.
We have tension. So tension is also the force, right? So T1 plus or minus
Plus
plus, and this is equal to mass into acceleration. What is mass? 5. Acceleration, you guys have counted.
2.
So T1 is 10. Right?
Sir, we can use like this also.
Yeah. So yes. What was the harm in this? Yeah. So how did you write then?
Sir, I was finding. I thought we can't use M into G.
No, M we already know. This is 5 kg block. Right. So M we already know, acceleration we have just calculated. So this is what we did in the previous question. The previous question was about normal reaction. This is about tension, right?
Yes, sir.
So is it giving you tension? In this question? So sorry for my PJ, but yeah, understood. Okay.
Yes, sir.
Okay. Now applying the FBD on the second 3 kg block in x direction. So equation of motion. Equation of motion is what? F net equals to, I'm dropping the x part. So ma. Okay. You guys just understand that this is the in the x direction. Okay, so what do I have in here for the 3 kg block?
Sir, T1, T2.
T1, T2. What is the sign on T1? What is the sign on T2?
T1 is negative, T2 is positive.
So T2 minus T1 is m into a. So m is how much? 3. Acceleration we have calculated. So T2 minus, and T1 we have calculated 10, and this is 6. So T2 is 10 plus 6, so 16 Newton. This was the question. So I forgot to write the free body diagram. This is 3G, this is N2, this is what? T2, and then this is T1, and then this is acceleration. Okay, so this is, oh, I forgot to write it here. So this is T1, and then this is acceleration. Yes, everyone understood about this 3 kg block.
Yes, sir.
Now let me write the 2 kg block, but everything we have calculated. So for the 2 kg block, so we have, this is 2 kg block, and this is T2. This is 20, and this is N3, and this is 2G, and this is the acceleration, right? So what we will have? We will have, if we write only the x direction, so F net is ma. So F net, what is F net, guys? What is positive? What is negative?
Sir, T2 is negative, 20 is
Yeah.
positive.
So 20 minus T2 is 2 into 2. Right. So we will get 20 minus 4 is T2. So T2 is 16 volt, right? We can use any block to calculate T1 and T2. Is this part clear? Elham and Rishita.
Yes, sir.
Yes.
Okay, so you guys please note it down. Please note down
So
this.
can you explain the 3 kg one again?
3 kg one again. Okay, so let
Yes.
me. Good, good. So whenever you have, yeah, this is what I like. Whenever you guys have doubt, please don't keep it with yourself, right? So we have this 3 kg block, okay,
Yes, sir.
and then you can see that this is the normal reaction, and then this is the 3 or gravitational force. And in the right hand side, we have this T2, right? In the left
Yes.
hand side, we have T1. And this is moving in this direction with some acceleration. So we don't have any other force, right?
Yes, sir.
So if we write only the x direction part, so in x direction part, this is moving. So we will have equation of motion. So we will apply the second laws of motion, which is F net equals to ma. So F net in x or in acceleration direction, which one is there? T2, right? So
Yes, sir.
T2 is positive and T1 is in the opposite direction. So what is the sign of T1?
Negative.
So minus. And mass we know this is 3, acceleration you guys have calculated 2. So this way, and we already know what is T1. T1 we have already calculated, right? T1 was 10 Newton. So this is 10 and then this is 6. So T2 is 16. Clear now?
Yes, sir. I understand. Thank you, sir.
Okay, so then please note it down, everyone.
Finished, sir.
Finished. Rishita and Anam, whenever you guys have noted it down,
Yes,
please
sir. I all finished.
finish. Rishita, what about you?
Done.
Okay, so now we know about all these three common forces, and we know about the equilibrium condition, and we also know about when they are moving, when the acceleration is not zero. So we can write the equations of motion. Now, you keeping that in mind, we have another thing which is added in that system. So now we have a pulley system, right? So what does it do? So we have, let's say, some pulley and some masses are hanging with this. So let's say that this is 5 kg, and let's say that this is 2 kg. So what will happen to these this system? What will happen?
Our 5 kg will go down.
Absolutely right. So 5 kg will go down and 2 kg will go up. Okay. So 5 kg will go up, go down. 5 kg will go down and 2 kg will move up. So which means that we have acceleration in the downward direction and we have acceleration in the upward direction. And they are same. They are same because we have these three conditions that we have to follow. One is that One is that the pulley is massless. right? Second thing is that the uh, string string is massless, and the third thing is that string is inextensible, right? So if string is inextensible, then tensions are same, acceleration is same. If this pulley is massless and string is massless, then this would be the same tension, and this would be the same tension. The tensions are same. Okay. Whenever these are inextensible, so tensions are same, right? They are massless, so they are massless, which means that tensions are same. And this is inextensible, so which means that they are moving with same acceleration. And if this pulley is massless, which confirms that there is no force at this point. So the tensions are always the same, right? So these are the three conditions for a pulley system. Is that clear?
Yes, sir.
Yes, sir.
So because of these three conditions, we have same acceleration going downwards and same acceleration going upward. And we have both the masses feel the same tension. Okay, because of these three conditions. So now we will do some question based on this pulley. So let's say that we have this pulley, and then we have this 5 kg, and then we have this this better picture. So you guys will tell me about all the forces. Now you guys have a good hand in, or good remembrance, whatever we should say. So now you guys are familiar with all the forces, right? So now you guys will tell me about the free body diagram. So this is 5 kg and this is 2 kg. Okay. And this is the tension in upward direction. This is the tension in upward direction. This is acceleration, and this is the acceleration. So we have to write how many free body diagrams do we have to write?
2.
Two, right? Because we have two blocks. Okay, so on this block we have this tension and this downward acceleration. What do we have? Do we have anything else?
Sir, gravitational force
Gravitational force. Good. So we have this
5G.
5G force, and on this block also. So we have this 2G gravitational acceleration. So you guys find out what is the A and what is the tension. Please find out and tell. You have these two blocks. Apply the Newton's law and tell me the answer. Now you guys have good hang of the problem and you guys can easily draw the free body diagrams. So you guys tell me what would be the A and tension.
Side got A as 10 meter per second square.
A is 10 meter per second square. Good. And what is T?
50.
50 Newton.
Mm.
Okay, so this is what Akib has got. Rishita and now what is your answer?
So I'm not getting. I'm getting confused.
Okay, no worries, no worries. So, Rishita, what about you?
So I think I got it wrong.
Oh, you. So, what is the answer that you got? Don't worry about the wrong or right answer. So, what is the answer that you got?
6 meter per second square as A, so I think it's wrong.
And T is what?
Then I didn't calculate
Okay,
that.
okay. So, good, good. The important thing is that you guys at least try. So, we have to write the free body diagrams in two parts, right? So let us write the FBD at 5 kg. So we have this 5 kg block, and this is tension, and this is oh, so this is acceleration, right? And then we have this force due to gravity, 5g. So this is moving, which means that we have to write the equation of motion, right? So it says that F net is ma, and you know already the sign convention. So which is positive and which is negative?
So T is negative.
And yeah, T is negative, which means that this is 5g minus T, right? This is equal to mass is how much?
Why is T negative?
Yeah, because acceleration is in this side, right, Elham?
Yes, sir.
And T is in the opposite side. So whenever whatever force is in the opposite side, we take it as negative, right?
Yes, sir.
So this is 5 and A we have to calculate. So what is this is 5G. So 5G and let me write it in here. So this is 5G minus 5A equal to T, right? Now let us write the FBD. So second thing is that FBD at 2 kg block. Okay, so if we write the FBD of 2 kg block, this is 2 kg, and acceleration is going upwards, right? Tension is going upwards. And then what is gravity is down. So what would be the equation of motion, Alam? Yes. What would be equation of motion and arm? So we have to write all the forces are there, right? We have to check the signs and then we have to just yes, Salam. Any confusion?
Listen.
Yeah, I can hear you. So yes, what would be the equation of motion, Elam? I guess your mic is not working. Yes, Rishta, you tell. What would be the equation of motion? Yes, Rishta.
Um,
Yes.
V square F
No, no.
equals
Yeah, F net equals to M.
M A
So then what would be in here?
2 into A.
2 into A. So 2 into A is in the right hand side. What is total F contributing in this block? What are the forces? You have only two forces, T and 2G, right?
Gravity.
2G minus T.
2G minus T. So alarm is saying 2G minus T. Why do you have negative sign in tension? Will it
It's
be
2G plus T.
okay? So 2G plus T. So why
T
there is a positive sign in 2G?
T minus 2G.
So T minus 2G,
Oh, okay, sir.
right? Okay, so you guys have to practice some questions, right? We have to count all the forces which are acting and equate it with MA. So MA always be in the right hand side. Always remember, all the forces which are acting on that block, we only write those forces. Okay, guys. So
Yes, sir.
so now what do we have? We have T equal to 2A
2A
plus
plus 2G.
2G. So this is equation second, and this is equation first. So if we write the value of T in both the equations, so comparing or from equation 1 and 2. So from equation 1 and 2, what do we have? 5G minus 5A equal to 2A plus 2G. So this goes in the right hand side and this goes in the left hand side. So this is 2A plus 5A. So this is 3G. Oh, what did I write? So 5G and minus 2G. And then this is 2A plus 5A. So this is 3G and then this is 7A. So A is 3 into 10 by 7. So this is 30 by 7. Right. 30 by 7 meter per second square, which is how much? Which is 4 point something. Okay. And what is my tension? Tension is 2A plus 2 into 10, which is 20. So 2 into A by 20 plus 20. So this is how much? This is 60 by 7 plus 20, which is 60 plus 140 by 7, which is 200 by 7 Newton. So this is my tension. Is this part clear, everyone?
Yes, sir.
So this is how you solve the pulley system. What you do is that this is how this free body diagram is important, right? So we write all the forces on each block and then we write the free body diagram separately. So if you guys have any question, please ask me and please note down this problem. Okay, so you should not have any confusion, guys. Right? Everything clear, Rishita, Elam, and Akif.
Yes, sir.
And how did you get 10 meter per second square and 50 Newton, Akif?
Sir, I used F is equal to MA.
Yeah. So then
First, I
what?
took 5G, I turned it into Newton. So 50 Newton, and then 2G, I turned it into 20 Newton. And then I added, I got 70 Newton. And then I plus the both of the kg, I got M. So I divide 70 by 7, I got 10 meter per second square.
Please check the calculation where it was.
Yes, sir,
Right.
understood.
Okay, you guys, please note it down, and whenever you want me to solve this problem, please me to scroll down the screen, guys. Okay. So now next thing would be tension, and not the tension. The next thing would be that we add friction. So we understood about three common forces, and then we'll understand about other forces, which is friction, and then spring force. So then we will combine these two in the calculation. So then we'll have to find out the by diagram. And the last topic is circular motion. So yeah, only three topic or two or three topics are remaining. So in the next week, this would be over.
Yes, sir.
Okay,
Finish, sir.
whenever you guys finished, Rishita and Ram, what about you guys?
Done, sir.
Yes, sir, done.
Okay, so please note down this part. So which chapter you guys found difficult? Yes, guys. So
Sorry, sir.
we studied motion in 1D, motion in plane, and then laws of motion. So which chapter you guys found difficult?
Okay, sir.
No, I'm asking that which chapter
Sir,
you guys
motion.
found motion in 2D.
No, sir, plane.
Your voice is breaking. Motion in 1D. Okay, so yeah, whenever we complete at least 5 chapters, then I will revise the okay. So noted, everybody.
Yes, sir.
Yes, sir, done.
Yes, sir.
Good. So we'll stop at here, and the next class